Hi guys, Missy walking you through the CO2 car project. And yeah, so we are going to be designing cars and then using CO2 canisters, which are just little metal containers that have CO2 that when they get punctured, they like shoot off the CO2 and propel your car forward. And this is a fun project to think about aerodynamic principles, which is what I'm going to go through here. And it's just another thing that we can do with AutoCAD, so I also think it's a cool thing to end the semester with. And by semester I mean quarter. There's a couple things I want to go through with aerodynamics. Oh, I'm in the pink. Let's go up here. Okay, with the aerodynamics, there are four main forces that affect how an object moves through the air, which is what aerodynamic means. So drag is kind of a combination of two forces, and so it's an overall thing that will work against the acceleration of your car. Acceleration meaning how fast it's going to go. And so the drag is really what's holding your car back. There's frontal pressure, which occurs when tiny molecules of air hit the front of your car. So this is your car, and it goes right here, boom, and is forced away to make room for other molecules to hit it. So that's how it goes over. If your car is flat like this, the air only can go up, and so that's gonna not help your car move forward at all. But if it's more slanted, kind of like this, the air can go over that way. Versus rear suction, and that occurs when there's an empty pocket of air in the back of your car, resulting in a vacuum cleaner effect that pulls your car backwards. So if this is your car again, and this is the back of the car, if your car is designed in a way that it pulls the air down and then underneath a little bit, it's going to be pulling your car backwards, which is the exact opposite thing of what you want to have. The other two forces are lift, which it's similar to air, but it to drag, to rear suction, I'm sorry. But it causes your car to lift, which is good because that means you're going to reduce the friction, which is the amount of heat and traction that your wheels have. And it also can just help move your car faster because it reduces that friction. And downforce, which is the high pressure and curved surfaces that cause the car to be pushed down. Now, let's look at this. So we've got a car here, and we're going to look at different forces. All of these arrows are how air moves. So that's the flow, velocity, and density. Green means the air is able to move fast over that area. Yellow means it slows down, and orange is slowing, and then red is like high force, meaning the air can't really move. So move, slow down. And the air just kind of halts right here because there's a big flat spot of the car. So the air will either go under the car or up above the car. This air causes some lift to happen, so that helps move your car forward. Downforce is this curved surface of the windshield, and again, that's another frontal thing to slow down. And then come up and over. Again, these green is lift, which is great, helping the car move forward, versus these are the areas of vacuum that's kind of pulling your car backwards. So think about, avoiding the flat upright surfaces in the front of your car to try to remove that turbulence and have a little bit more lift happening, a little less drag. Avoid the flat upright surfaces in the back of your car to reduce rear suction so we don't get our car moving backwards. And then shield as much air at the bottom of your car to maintain traction. And that just means keep your car a little bit lower to the ground. Keep the surface area exposed to oncoming air to a minimum. So think about surface area of an object and how to restrict surface area. I'm not going to tell you exactly how to be successful with this project, but just because I don't want to give you an exact answer and I want to see what you guys come up with, but I want you to think about surface area of objects. So physics, force is thinking about mass times acceleration. So mass is talking about how many atoms are in an object, and then times the acceleration, again, how fast it's moving. Heavier objects require more effort to move at the same speed as a lighter object, so that's affecting the force. So think about it this way. If I asked you to push a car out of a ditch, would you rather push a CO2 car out of a ditch or a real car out of a ditch? You're probably going to want to say CO2 because it's going to be easier. So here's a question for you. Which one of these bicycles would go faster down a hill? So this one here is a mountain bike, and this one's like a road bike. So the heavy mountain bike is great. It's really durable. It's really good for rough terrain, going on trails and beaches and all sorts of things. But it does require more energy versus a light racing bike, which is really fast. It's good for long distances, and it requires less energy to run. This one is going to go faster down a hill because it's lighter, and it also requires less energy. So you want to avoid unnecessary extensions or ornaments that might add weight to your car. The lighter that you design your car, the more power will be used out of the CO2 cartridge. So that's again more force, causing your acceleration to increase. Yeah, so you'll go further in less time. So some little things with the car design. You want to create a multi-view file of your car design. So again, you have to have at least 3 views. You have to have a top view, you have to have a front side view, and you have to have a back. So that shows me where the CO2 cartridge is going to go. But if you want to include another view of the front, it does just make it a little bit easier for me. You're going to be graded on the design and how much effort I see that you're putting into the design, if you're thinking about it, if it's detailed and it's not just like a circle. Dimensions, I do give you some dimensions that you have to follow on Canvas, and that is again just because there's some restrictions we have to follow with this. You need to follow these aerodynamic principles. So if I notice that you just have like a super flat car in the front, it's like, I don't know if you really got the point of the assignment. The goal is to go fast. You do need to explain in a paragraph why you designed the car the way you did. Again, a paragraph has a topic sentence, 3 body sentences, or at least 3 body sentences, and then a conclusion sentence as well. So that's the paragraph. Tell me why you made the design the way you did. And then you are graded on speed as well. It's really important that you read through the assignment on Canvas because there are very specific dimensions you have to follow. Big things you need to know, you have to include axles, and axles are where the wheels get attached. You're going to have just a little metal rod, and there's a wheel on each side of it. So you need to tell me where you want that little axle hole to be drilled. You have to include a blowhole, which is a place for that CO2 cartridge. It's about 2 inches in length. So that's going to be a hidden line for you. And I just need to know where to put it on both the back view, and I want to make sure it doesn't hit the axles in your side view. I definitely want you to have fun and be creative with this assignment. I want to see what you guys come up with, and it should be cool. Your designs are due at the latest at the end of the day on Monday so that I can cut them out Tuesday and we can finish them up and then race them Wednesday. So, good luck.